What if humanity's most powerful discovery didn't explode in a headline, but hummed quietly in a lab while the world scrolled past? Right now, while politicians argue over climate targets and carbon credits, scientists in Australia are testing quantum batteries that hold energy 1,000 times longer than anything before. Across the Pacific, fusion reactors in California are producing more power than they consume. Those two sentences alone should make every oil executive nervous. For the first time, clean energy isn't playing catch-up, it's overtaking. The same physics that fuels the sun and the same quantum rules that once looked like science fiction are beginning to merge into something that could shatter the economics of fossil fuels forever. Because when energy can be stored almost indefinitely and generated endlessly from seawater, scarcity itself starts to die. But here's the riddle. Why isn't this everywhere? Why isn't every news feed screaming, "The fossil fuel era is ending"? Could it be that the people who stand to lose the most have more control over the story than the people creating the solutions? Hold that thought, because the next few minutes will reveal how breakthroughs in quantum storage and fusion ignition are rewriting energy history, while most of the world still thinks we're waiting for change. For more than a century, the world has run on the same equation. Burn fuel, release heat, drive progress. Coal gave way to oil, oil replaced by gas, and each promised prosperity at a hidden cost. Today, that equation is breaking down under its own weight. Global demand for energy is soaring. Data centers alone are set to consume as much electricity by 2030 as entire nations do now. Yet fossil fuels, once the pillars of that growth, are collapsing under price volatility, political friction, and the undeniable math of carbon. That's where three improbable breakthroughs collide like tectonic plates shifting beneath our feet. First, quantum batteries. Tiny systems where energy isn't stored chemically like in lithium-ion cells, but through the bizarre rules of quantum physics. Researchers at RMIT and CSIRO extended their energy lifetime 1,000-fold, moving from nanoseconds to microseconds. Their goal? 1 second retention, enough to power real devices. Second, fusion ignition. After decades of cynicism, scientists at Lawrence Livermore National Laboratory finally crossed the threshold in 2022. More energy out than in. And they've done it again. Private investors have poured nearly $10 billion into scaling it, with Microsoft already signing fusion power deals for delivery before the decade ends. Third, engineers at General Atomics cracked a 70-year-old physics barrier, the Greenwald limit, allowing denser, more stable fusion plasma than ever thought possible. Put together, these advances form a singular story: humanity within sight of limitless clean energy. So why doesn't it feel like the dawn of a new era? Why do we still treat renewables as nice extras instead of the cornerstone of civilization's future? That disconnect between breakthrough reality and public disbelief is where the real battle begins. Let's unpack the miracle hiding in plain sight. Because these aren't sci-fi headlines, they're live experiments rewriting the future of power. Quantum batteries don't rely on chemical reactions, so they don't wear out. Their energy is stored in the strange behavior of quantum states, electrons entangled and synchronized like a microscopic orchestra. When a single particle changes, every other particle reacts instantly, letting energy flow with near-zero loss. Theoretically, these devices could charge almost instantly and keep that charge indefinitely. No degradation, no resource wars over lithium, no recycling nightmare, just clean, persistent capacity. Fusion power operates on an even grander scale. Instead of splitting atoms like fission power plants, fusion joins them, releasing nearly 4 million times more energy per reaction than burning coal, yet producing zero carbon and minimal waste. More astonishing, its primary fuel, hydrogen isotopes, exists abundantly in seawater. One bathtub of ocean water contains enough fusion fuel to power an individual's lifetime energy needs. Tie these together, and the implications spiral outward fast. Fusion provides endless power. Quantum batteries store it effortlessly. AI-optimized grids distribute it globally. Imagine cities running without smokestacks, transportation running silently, baseload power so cheap it flips entire economies. But nothing this revolutionary arrives unopposed. Every breakthrough threatens trillions of dollars tied to fossil infrastructure. And as history shows, those interests don't vanish quietly. They fight back hard. Because somewhere between discovery and distribution lies the friction point where innovation meets denial, and power, both electrical and political, is on the line. This is the moment we've spent a century crawling toward, and most people still can't believe it's real. For decades, energy revolutions meant slightly cheaper solar panels or marginally bigger wind turbines. Those were incremental tweaks. What's unfolding now is an extinction-level event for fossil fuels, a handoff between centuries. Because quantum batteries and fusion aren't extensions of the old system, they erase its limits. Imagine energy that never degrades, fuel that never runs out, and a grid that never flickers. Economists call that post-scarcity. For humanity, it means the end of energy poverty and the start of abundance as a birthright. Yet the drama isn't just technological, it's geopolitical. OPEC's market share is slipping. Oil giants are quietly investing in fusion, startups they once dismissed. Nations that once traded oil for influence are now scrambling for lithium, tritium, and critical minerals. The world's balance of power is shifting from the ground beneath our feet to the labs designing atoms for clean power. And inside that turbulence lies the psychological twist. After 50 years of waiting for impossible breakthroughs, they've arrived, and the world's biggest challenge is believing them. Because the clean energy revolution won't be televised with fireworks. It'll slip into our devices, our cars, our cities, until one day we realize the hum of engines and the smell of diesel belong to a vanished age. Which leads to one final question, the only one that really matters. Now that the future of energy has arrived, who gets to control it? Picture a world where energy no longer dictates power, but possibility. Cities glow at night powered by fusion, so efficient their lights feel weightless. Homes charge instantly through quantum cells, so durable they'll outlive their owners. Air is clearer, oceans cooler, and the term energy crisis fades into the history books beside horse-drawn carriage and coal lamp. That isn't a fantasy. It's a forecast already ticking into existence. The only real question is speed. How fast these technologies scale, how soon governments stop defending the past, and how ready humanity is to handle abundance. Because abundance reshapes everything. Economics, politics, and the rhythm of everyday life. Once power becomes limitless, scarcity shifts elsewhere, to wisdom, ethics, and trust. Who owns the fusion grids? Who profits from quantum storage patents? Who decides when clean becomes controlled? The fossil fuel era isn't ending because awareness changed. It's ending because physics does not negotiate. And now that physics is on our side, the playing field resets. So as you unplug from this video, consider this. The next great power struggle won't be fought over oil fields or gas pipelines, but over data centers, minerals, and the invisible particles dancing inside quantum cells. The clean energy age has already begun, and somewhere, as you watch this, a reactor is igniting, a quantum battery is charging, and the fossil fuel empire is quietly running out of tomorrows.